For generations, people have lifted their eyes toward the night sky searching for answers. Every equation we've written, every telescope we've built, and every theory we've proposed has been an attempt to understand one enormous question. How does the universe truly work? For decades, modern cosmology seemed to provide a convincing picture. The laws of physics appeared reliable, galaxies evolved according to predictable models, and the story of the universe felt increasingly complete. Then the James Webb Space Telescope began looking farther than any observatory before it. What it revealed wasn't simply beautiful, it was deeply unsettling. Ancient galaxies appearing far earlier than expected. Planetary systems that challenge accepted theories of formation. Perfectly shaped gravitational lenses. Massive cosmic structures displaying an unexpected degree of organization. One discovery after another has forced astronomers to ask whether some of our most trusted assumptions need to be reconsidered. This isn't about proving science wrong. It's about confronting evidence that doesn't fit comfortably within our current understanding. The deeper Webb peers into space, the more the universe seems to resist our expectations. During a series of breathtaking deep-field observations, the telescope captured some of the sharpest images ever taken of the distant cosmos. Hidden within those spectacular views, however, were details that immediately attracted the attention of researchers around the world. Inside the famous galaxy cluster Abell 2744, astronomers noticed unusually precise alignments among distant sources of light. Certain structures appeared remarkably symmetrical, displaying an order rarely associated with the chaotic process of galaxy formation. Elsewhere, observations of the barred spiral galaxy NGC 1365 revealed complex patterns of motion that continue to be studied. While these measurements don't overturn the laws of gravity, they provide valuable data that may improve our understanding of how matter moves within massive galaxies. As more observations accumulated, scientists realized that unusual features weren't isolated to a single target. Again and again, Webb revealed distant systems whose appearance seemed more organized and mature than expected. Across billions of light-years, certain large-scale patterns appeared surprisingly consistent, encouraging astronomers to investigate whether previously overlooked physical processes could be responsible. Of course, researchers remain cautious. Nature has often surprised us before, and history reminds us that apparent mysteries frequently find perfectly natural explanations. Even so, every unexpected observation becomes another clue in a much larger investigation. Perhaps the universe is more structured than we once believed. Perhaps there are physical mechanisms still waiting to be discovered. One of Webb's most celebrated achievements involved directly imaging an enormous exoplanet known as HIP 65426b. Orbiting hundreds of light-years from Earth, this giant world immediately challenged conventional ideas about planetary formation. The planet contains several times the mass of Jupiter and circles its young star at an extraordinary distance, far beyond where traditional models predict such a massive planet should easily form. Its parent star is estimated to be only around 15 million years old, remarkably young by cosmic standards. Under current theories, building a planet of this size so far from its star presents significant challenges. Material in the outer regions of a young planetary system is generally thought to be too sparse for rapid formation on this scale. Scientists have proposed several possible explanations. Perhaps the planet formed closer to its star before migrating outward through gravitational interactions. Perhaps it emerged through a different formation process than those commonly seen in our own solar system. Or perhaps observations like this reveal that planetary evolution is more diverse than existing models suggest. At the moment, no single explanation has solved every question. HIP 65426b remains one of the clearest reminders that nature often proves more creative than our theories. Another breathtaking image captured by Webb demonstrated the incredible effects predicted by Einstein's theory of general relativity. The telescope observed a spectacular gravitational lens known as an Einstein ring, created when the gravity of a massive foreground galaxy bends and magnifies the light from a much more distant galaxy positioned almost perfectly behind it. These rings are already considered among the rarest and most beautiful phenomena in astronomy. Yet this particular observation stood out because of its extraordinary symmetry. The circle of light appeared astonishingly complete, reflecting an almost perfect alignment between observer, lens, and background galaxy across unimaginable cosmic distances. Although gravitational lensing is a well-understood consequence of Einstein's equations, achieving such near-perfect geometry remains exceptionally uncommon. Rather than challenging physics, discoveries like this highlight just how remarkable the universe can be. Events separated by billions of light-years can align with breathtaking precision, allowing astronomers to observe distant galaxies that would otherwise remain hidden from view. Every one of these images is more than a beautiful photograph. They serve as natural experiments, helping researchers measure invisible dark matter, calculate cosmic distances, and investigate how gravity behaves across the largest scales imaginable. With every new observation, James Webb continues to push the limits of what humanity can see, and, perhaps more importantly, what we still have left to understand. As impressive as those discoveries were, they were only the beginning. Some of James Webb's most surprising observations involve galaxies that appeared to have formed astonishingly early in the history of the universe. According to the standard cosmological model, the first few 100 million years after the Big Bang should have been a period when galaxies were still small, irregular, and slowly gathering mass. Instead, Webb has revealed systems that seem far more evolved than expected. Several distant galaxies appear unexpectedly bright, massive, and chemically mature despite existing when the universe was still in its infancy. Their existence has prompted astronomers to revisit long-standing models of galaxy evolution and ask whether stars and galaxies formed much faster than previously believed. It's important to understand what this means. These observations do not automatically disprove the Big Bang. Instead, they suggest that our current models describing the earliest stages of cosmic evolution may be incomplete. Scientists are now refining simulations, testing new ideas, and exploring whether unknown physical processes accelerated galaxy formation during the universe's earliest chapters. That is how science moves forward, not by ignoring unexpected evidence, but by investigating it. Another mystery emerged when Webb observed regions where the path of distant light appeared distorted despite the apparent absence of visible objects capable of producing such powerful gravitational effects. Normally, gravity bends light because of massive bodies such as galaxies or galaxy clusters. In several observations, however, researchers found lensing effects that seem stronger or more localized than expected based solely on the visible matter present. The leading explanation still points toward dark matter. Although invisible, dark matter is believed to make up most of the universe's mass, shaping galaxies and influencing the motion of stars through its gravitational pull. Yet Webb's detailed observations are helping scientists map these hidden structures with greater precision than ever before. Some regions appear to contain dense concentrations of unseen mass, creating gravitational distortions that continue to challenge existing simulations. Rather than weakening the dark matter hypothesis, these discoveries are encouraging astronomers to improve their understanding of how dark matter is distributed throughout the cosmos. Naturally, more speculative ideas have also appeared outside mainstream research. Some have suggested the possibility of unknown forms of matter or entirely new gravitational physics. Others have wondered whether these hidden structures point toward phenomena we have not yet discovered. While such ideas capture the imagination, they remain hypothetical until supported by strong observational evidence. One of Webb's most fascinating contributions has been its ability to study the enormous network connecting galaxies across the observable universe. Astronomers call this vast arrangement the cosmic web, a gigantic framework of galaxy clusters, filaments, and immense empty regions stretching across billions of light-years. The telescope has revealed these structures in extraordinary detail. Certain filaments extend across astonishing distances, linking countless galaxies through streams of gas and dark matter. Their scale alone is almost impossible to comprehend, forming one of the largest known patterns in nature. Researchers continue studying whether subtle regularities within these enormous structures can be explained entirely through gravity acting over billions of years or whether additional physical processes influenced their development. Most evidence continues to support the standard picture of cosmic evolution, yet every new Webb observation provides higher resolution data capable of refining that understanding.